Good afternoon, everyone. Thanks for coming. I'm sure today's been an exciting day, starting with the first look at Silverlight 3 in the keynote. Silverlight 3 is certainly shaping up to be a great platform for writing applications on the web, whether it's a RIA, rich internet application, or a line of business application as well. We're also, for the first time today, publicly releasing what we call .NET RIA services, intended to make writing line of business applications much more simpler, much more productive. And you saw a glimpse of that probably in the previous talk. How many people were here in the previous talk by Brad who introed this? Most people. Great. I can probably skip half of my first demo and show some more unique stuff and also keep some time for Q&A. My name is Nikhil Kothari. I am a software architect at Microsoft in the .NET developer group. I've been working on the web platform for ages. Every time I look back, it's like, oh my God, another year. So I've been working on this space for a while. And this topic is really near and dear to me, not just because I work on this, but because I can kind of see myself as a customer of this technology if I were to go build a web application and put it on the web. And then the second thing why it's really near and dear to me is it allows me to take the two things I've worked on for the longest time, Silverlight and ASP.NET, and bring those two together in interesting ways. And hopefully you'll find it just as interesting and compelling. So the quick agenda is I had planned an intro demo, which I'll breeze through a little bit, since you've probably seen it by now. And then I have more demos, complemented with some conceptual stuff. Hopefully the demos will make it a little bit more tangible, a little bit more concrete. And then I'll try to show you a few things that are beyond the basics, some ideas, some early ideas, some concepts. And so the code isn't so much important there as much as the concept of what .NET RIA services brings to the table and how you might be using it. So let me switch over to this demo, and it's basically hello world of .NET RIA services. I've got a database, I've got a data model, I've got a server application, I've got a client application, all in the same solution. My data model is really simple. I'm going to be using link to SQL, so you can kind of see some variety. Brad was using link to entities. I've got basically product, category, vendor, three simple tables in my data model. And one thing you can start seeing here is a little structure to my application, and I'll stress on this just a little bit more when we get to slides. I've got my data model in a folder called data access, and then I've got something called domain logic, and this is where some of the .NET RIA services kicks in. I've got my catalog class, which represents sort of my particular application domain. It's basically a catalog of products. It derives from link to SQL domain service, and it has get products, insert product, update product, and so on. Straightforward stuff. So I've got my domain logic here, and then I've got my client, and it's got a simple page, with a data source, the domain data source control that allows you to bring in this sort of data and this domain logic into your presentation tier in a declarative way. So I've got my domain data source that points to an instance of catalog, which is defined up over here. So I've defined catalog on the web. The .NET RIA services infrastructure makes it available as an object on the client, and you'll see more of this in a bit. I can refer to it in a domain data source, and then I've got a data grid and data form bound to it. So let me just run this app. This will look like a very straightforward repeat, and then I'll go and do one new thing that you haven't seen before. So I've got a data grid. I can select different rows, and the selection is, since they're both bound to the same data source that's tracking selection and currency, the data form also updates. So this is sort of just setting up the stage. Now the thing I wanted to add to what you've already seen a couple times now is adding some support for projection and shaping of your data. So you can see that my product here has a category ID and a vendor ID. And that's probably not very useful to show to a user. You'd rather see the vendor name and the category name. So let's kind of go do that. So in my data model, in my logic here, in a metadata class, what I'm going to go do is add some metadata to say, whenever you send down a product, go ahead and also include the vendor name and the category name. So let's see what's happening here. I've got a partial class product, and this is in my server application. So I'm augmenting my data model. I'm going ahead and saying there's a metadata type associated with this. And what this does is it allows me to add additional metadata to the product class, and that metadata will make its way all the way down to the client. So what I can go ahead and, on this metadata class, I can go ahead and add some attributes to vendor and category and say, I'd like to include the vendor.vendor name on product as vendor name. Oops. And I'd like to do the same for category. Go ahead and do that. So what this does, these two little metadata attributes say that whenever product is sent to the client, whenever it's serialized and sent to the client, go ahead and include the vendor name property off of the vendor and the category name property off of the category. So that's great. I need to do one more thing, which is when I load products from my database, I also need to load the vendor and the category. Otherwise, it's just going to be null, right? So let me go ahead and copy that code just to save myself typing errors and reduce the time you have to watch me type. Essentially, what I'm doing is using the link to SQL API for going ahead and creating a data load options class and saying, whenever product is loaded, go ahead and load product.category, and same thing with vendor, and set that as my load options for my context. And so now when I go ahead and say context.product, the SQL query that's formulated includes the instructions to fetch those two additional entities as well. And so with that change, let's go ahead and build. Actually, let's go ahead and build the client. And let's run this. So what you can see now is my view of product on the client just changed to include category name and vendor name. So this was sort of the basic demo app, and I just added this ability to show you writing actual projections. Just to complete, for the sake of the complete scenario, I could also go ahead and create a new type on the server. For example, I could create a product presentation object, or a product DTO, or a product view, whatever you want to call it, whatever your naming patterns are. Define the exact structure, create that class, and send it across. But this just shows you how you can take a few metadata attributes and influence the overall end-to-end experience with .NET RIA services. So let me switch back to slides, and we'll see a lot more as we go along. I did want to share, before we go along, I did want to share a little bit about where we're coming from. What was our driving vision behind this? The first and foremost thing is writing a RIA application is just plain hard. For the longest time, if you've written ASP.NET applications, or if you've written Windows Forms applications or WPF applications, you've almost very likely been talking to the database directly. You've had that luxury that you could because you had the data APIs and you had the ability to reach to the actual database. And so you're writing a two-tier app. With Silverlight, you pretty much don't even have the choice. You have to write an n-tier app where at least n is at least 3. And so you have to have your client side be able to talk to some middle tier that then talks to a database. And part of the just being on the client, part of what comes along with that is asynchronous data access is one. Figuring out what's the right sort of model for how much data you bring down to the client, what changes you make, when do you push the changes back, how do you handle errors across the tiers. Those are all hard, or lots of plumbing at least, if not very hard, that you really don't want to repeat every time you write an application. And if I were to go add things like offline, well, that just complicates the matter even more. And so we wanted to really simplify RIA development. And this is our first step in that. The second thing that motivated us, that guided us, is looking at some of the success with ASP.NET in the sort of writing line of business applications. ASP.NET comes with a lot of building block components that are really scenario specific. If you want to do a data thing, there's a slew of controls. If you want to do security, there's a slew of controls. If you want to do composite UI, there's a slew of controls. So we wanted to bring some of that same flavor to Silverlight. And by providing controls and building blocks that are focused on scenarios as opposed to a ton of small micro building blocks, if you will. So those were the two sort of biggest sort of motivators behind all the work that we're doing and showing today. So I wondered what were the, and sort of out of those visions and goals, what were the value propositions we intend to bring to you as part of this technology? The first is data is just critical to any application, and we wanted to address it in an end-to-end manner by really looking at how you get data from the server all the way to the client, work with data, visualize data, modify data, and send the changes all the way back to the server and everything that goes in between. So that's kind of one of our value propositions. The second is, and this is probably a little bit unique, and I think probably what differentiates some of what we're doing is we're looking at the client and server pieces as one application. Your application just happens to span across multiple tiers, and I'll go into this some more, because I think this is one of the key things that we're bringing to the table. And then last but not least is, as I said, we want to provide building blocks that are higher up the stack, and they target scenarios. But we also want to guide people better in terms of how they structure their application out of the box so that they land in a better place without every developer having to think of how to do that. Now, our prescription might not be, it's certainly not unique, and it's certainly not the only one. It is one amongst several that work. And we're targeting frameworks around it, targeting tooling around it, so it starts to feel more natural and more mainstream. So let me talk a couple of slides before we go back into demo. So I mentioned end-to-end data. And when we look at existing frameworks, there's lots of APIs for data. We have several different APIs. And the APIs allow me to access data, allow me to edit data. Some APIs let me do a little bit more. But you have to stitch together all the different APIs and think about the overall problem space. So here, by end-to-end data, I want to go with .NET RIA services a lot beyond CRUD. So it's not just about accessing and modifying data. It's about how do you insert your particular application logic, your particular domain logic into that space and control what's allowed, what's not allowed, what are the policies, what are the rules around that. Second thing is shaping of the data. You saw me do a little bit of shaping of data with the vendor name, category name, but it goes a lot more beyond that in terms of sorting, paging, filtering, all of those operations. Since we are talking about end-tier apps and exposing data and operations, there are rules around validation, who's allowed to do what, authorization, as well as what happens when two people modify the same row. How do you handle a conflict? How do I encode a policy for resolving a conflict on the server so that you might have some rules saying, hey, a manager can override an action done by an employee, for example. How do you write that rule and resolve conflicts on the server? And then when you can't resolve, then you do send all the information back to the client so that you can take some user input into resolving the conflict. That's what I mean by end-to-end data. And I'll show you a little bit of validation in the demo that I'm going to do next. And then last but not least, since this is a client app disconnected from a middle tier, you want to think about what's the right scope of doing work, how much data to bring down, when to commit changes. You don't want to necessarily commit changes on every row that's being edited or being added. You might want to think about what's the right level of granularity. And so batching is equally important. And then batching leads very quickly into offline. How do I do a bunch of work while I'm disconnected? And then when I connect back, I want to go and send all those changes back to the server. So those are some of the problems that we want to make easier and provide prescription around how to go and implement in your app. So the second thing I said in terms of value propositions was this idea that you have a single application, or that we have a unified view over the client and the server. So specifically, .NET RIA Services is about creating an app model that spans multiple tiers and that you have a single logical application. The client is just an extension of the server. So let's look at a traditional web application that is HTML based, maybe Ajax, and how it's structured. You typically have your data store, whether it's a database or some services that you're going to call into and use. You have your data access layer that lets you go do that. And then you have this application logic that basically controls how you perform data access, what operations are allowed. And next, you have a presentation logic, whether it's server-side rendering for generating HTML or what have you. It's basically this block of code that runs on the middle tier in your web application with pretty much direct access to the application logic and direct access to the data access layer. That's the general makeup of the web application as it exists in most web applications today. And then you're projecting HTML. You certainly can have some Ajax. Some applications have more, and some applications have less. And then just to complete the picture, you also potentially expose services so that other applications can reach into your application logic or your data and do interesting things. With Silverlight, what we're doing, essentially, if you look at it in a way, is moving this presentation logic, or a big chunk of it, to the client. So it's now running in the browser in a different tier. Just because that happened, we don't want to make the programming model, the development experience, completely different than what it was before. So we want that direct connection, so to speak, still very much there, and be a sort of natural thing. And a large part of .NET RIA services then is to restore that direct connection. And in fact, the reason why we think of it that way, or why we think we should be doing it that way, is because we look at a rich internet application as not just these two parts that are completely independent, but as logical halves of one big rich internet application that just happens to span between these two tiers. Now, while we're doing that, there is obviously a network in between. That's not going away anywhere, and we certainly don't want it to completely disappear from our thinking. And so there is this network, and we want to make it possible for you to go write the right kind of interface in terms of how chunky the data exchange is, the right place to go add your authorization rules, the right place to go add your validation rules, and so on and so forth. And then to complete this picture again, of course, you can have presentation logic also reach out to external services directly from the client. So that's the picture that we have in our minds about what .NET RIA services is all about, and how we're taking this logic that runs in between these two boxes and providing that as infrastructure that you don't have to go write in every application you author. Instead, you can go focus on your application logic. You can go focus on your presentation logic. That lets you go expose richer data in richer ways. It lets you go create richer user experiences on the client. And that's what you can go focus on as an application author. So with that, let me switch back to demo. Close my previous one. Let me run this. Basically, what I have is I've written the skeleton of the application, so the UI. Most of the XAML's pretty much taken care of, and then I'll be filling in the guts of the application in terms of the logic and code. So I don't know how many people remember have been using ASP.NET for a while. Back in the ASP.NET 10.11 days, there used to be this app called iBuySpy. So it was this fun product database with funky products. So I'm using products and categories, which it's probably a not so interesting topic, and so hopefully the data makes up for some of that. But basically, I have this application. I want to show the list of product categories over here, allow you to select a category, show the list of products, allow you to edit a product, and then go save that. So let's look at filling this shell out. So the first thing I want to do is show you what I have in terms of my data model. It's actually very similar to what I just showed before. Same product, category, and vendor tables that have been brought from my database using link to SQL. And what I then have is a catalog class that has a couple of query methods, get categories and get products. And it, because I'm using link to SQL, derives from link to SQL domain service like before. And I've got a little bit of application logic here. Specifically, I want to order the categories by number of products, the count of products in a descending order. And I've got my products here where I've said every time you load a product, go ahead and load the vendor information just like before, and go ahead and filter out all discontinued products. So this is sort of the entry point into my system that says anytime you access categories and products, this is what you're going to go get, right? So then I want to go ahead on my client and go into my window, into my code, and let me show you what I have in terms of my XAML. So I'm going to be plugging data into that. So I've basically got an items control, which is sort of like a repeater, if you will, called category list, and it's just basically going to show me a button for every category of products that I have. I've got a grid somewhere here, a data grid, that's going to show me my list of products in an interesting way. So I've customized the columns and their look and feel, and you'll see that once I have data. And then I have a bunch of buttons that let me do certain things with products, like edit it, put it on sale, that sort of thing. So let's start writing some code. So I'm now in my client-side code, in my presentation tier code. I'll go ahead and create an instance of my catalog. So right off the bat, you can see I'm in my presentation tier, and I have this catalog class. It's just there because I wrote it as part of my application. And I can go ahead and instantiate that right in my constructor. And here you can see, again, it's a class. I don't have to think about URIs. It's just a class that's going to be there. And then let's look at what the object model on this is. So catalog has a property called categories. It has a property called products. And that's because my particular catalog object is exposing categories and products. I had get categories and get products. So those are a couple of lists that are designed to be bindable into UI. I can go take data grid and bind it to the products collection. I can go take the items control in Silverlight and go bind it to the categories. Now, those are empty lists. I need to load data into them. So I correspondingly have a method called load categories and load products. That's basically how I populate data into my client-side view, right? So let's go ahead and bind the category list dot item source equals catalog dot categories. So that binds the two up, and then I'll go ahead and load some data. Now this is an asynchronous operation. It goes out and issues a network request, and at some point later it comes back. But I don't have to handle the async callback because what we've done is created a collection of categories that raises change notifications. So one of the things that we're doing is trying to simplify async by using the power of data binding that's in the presentation platform. So you can go and do some work. As long as it results in some changes in the objects that you have, the UI will pick it up automatically. You don't have to handle async every time. And that's really key. So I've got my load categories. Let's just run this and keep making this work as I go along. So there's my list of categories, right? Now I want to handle the clicks on these so that I can go populate the list of my products. So I've got my event handlers already all hooked up. So I've got my category button click, and I'm getting the category object from the object that was bound into the UI. And what I want to go ahead and do here is go ahead and say products grid dot item source equals category dot products. And so from our data model on the server, we know that categories has a reference to a list of products. And so that is projected very much so on the presentation tier as well. And so I can go ahead and bind that. Now, obviously I haven't loaded all the products. So what I can go ahead and do is say if category.products.count is 0, I want to go ahead and load the products for that category. And now if you remember, I wrote a method called getProducts that basically took no parameters. I could have written a method that took some parameters, and that would have worked fine. But I wanted to show the person writing this class doesn't have to think of all the permutations in which you're going to access the list of products. Instead, I've exposed a iQueryable of product that lets me say, pass me in a query, and then that gets evaluated against the list of products. And so I'll go ahead and create a query here. iQueryable product query equals. So this is standard link. I want to use, say, p.category ID equals the selected category dot category ID. So I have this query now that I actually want to evaluate, and so I can go ahead and now say catalog.load products and use the overload that takes a query and pass that in. Oops. Don't have any user state, but so that does basically issues a call to load products. It takes the query that you created, serializes it, sends it to the server, invokes your server method, so it invokes your get products, takes the queryable, deserializes the query that came in against that queryable, and then it executes it, at which point the query goes all the way to the database. So I'm only fetching the list of products that I actually wanted, all the way through, across the data tier to the application logic, all the way to the presentation tier. So I think I'm missing a couple of lines of code just to kind of get the UI. So let me copy that. Just to show which category is currently loaded. And let's run this. So now we should start seeing some products as I select some categories. And so you can see the list of products was fetched. Now, none of the products for the other categories have been fetched. So when I go to, let's say, travel, that's when it goes and fetches that. When I go back to general, it doesn't have to go fetch anymore because I've already loaded. So what we have on the client is this catalog object that is stateful. Because the client is stateful, we're leveraging the fact that it is stateful and bringing down products and caching them. So you can go work with them, enumerate them multiple times without having to think about asynchronous access, right? You've got all your products down that you wanted to work with. So that's just showing you a little bit of link, how you can go write some link queries, send it to the server, how you can go bring some data and work with that data to bind it into the UI programmatically. You can do things declaratively, you can do things programmatically. If some people are familiar with the view model pattern, where you can go write code that's separate from your view, this pattern works beautifully with the view model pattern. So let's keep going. I want to now go ahead and implement editing. So right now, I don't have, all I have in my domain service, in my catalog, is basically get categories and get products. I don't have any update. So let me go ahead and copy some code, and then I'll talk to it. So here's where I'm writing update product. It takes the current product and the original product. What I want to do is a couple of things. I can go ahead and do the straightforward link to SQL code here, which is attach the product as modified. I also have this rule that I want to update the modified date anytime a product gets modified. So here's where I go write that rule. And anytime anyone comes and tries to update a product, its modified date is going to get updated to today. The other thing I wanted to do in this particular sample is go ahead and say, when a product is on sale, so if product is on sale, I want to throw a validation exception saying a product on sale cannot be modified. So I'm going ahead and going back to my database, looking at the current state of the product as it exists in the database, and determining whether the client is allowed to modify the product or not. So I've got that there. Now, what this update product does is it basically says, pass me in an updated product, and I'll go ahead and put it into the database. Now, that might work for some applications. It might not work for some other applications. You might not want to allow a client to sort of freely go ahead and update the entire product. You might want a very controlled access to what's allowed and what's not allowed. So let's say all I wanted to do was allow the person who's using the app to put in product on sale or to end the sale on the particular product. So I could go write that method, and I'll go ahead and copy that again. So what we have here, so I've got a method called toggle sale, and it takes a product. Essentially what we have is a stylized update method, right? It's not surfaced as an update as a normal CRUD. It's surfaced as a custom operation that makes sense for this particular domain of catalog. Again, what I go ahead and do here is get the product from the database, and if it's on sale, or basically flip it. And my rule is basically 75% or 25% off is on sale, and when you take it off sale, it goes back up to the normal price. Again, I update the modified date. And then what I'm also doing is, see this product coming in? I'm going ahead and updating that, a few fields on that, the unit cost, the on sale flag, and the modified date on that to whatever is in the database. And so what I'm doing effectively is I'm updating this particular product that was sent from the client. And part of what .NET RIA Services does in response is it takes all the changes you made in your application logic on the server and sends it back to the client and merges it in with the particular product instance that you have on the client. And so you'll see that working in just a second. Once I write a couple of lines of client-side code to invoke these two methods. So now I'm back in the client-side code. Here's my edit button. And the edit button, all it does is brings up a pop-up window with a data form. So I'll show you the data form. So here's my data form, and it's going to be bound to a particular product, and I want to allow you to edit the model number, model name, and description. And basically, in my OK button, I'm committing the edit. If that succeeds, if there's no validation errors, then I'm closing the dialog. So the editing itself is is per field, and it's taken care of by this data form. And then the other thing I have is this end sale or sale button, and that I want to code. So going back to my code here, what I want to do is say, this is my handler for the sale button. I've got my catalog. Oops. Oh, I know why. I did not build. So I updated the server, and the client now needs to be built so that it sees whatever is new on the server. And so now I can say catalog dot. Still don't get it. Did I make it private? Someone's paying attention. Thank you. Well, you can see now this was private implementation of the catalog, not exposed to anyone else. So if you want to expose it to whoever else outside catalog, you need to make it public. Let's build it again. There you go. So I can now call this method right here. And that's pretty much it. Now, what just happened here was I just made some changes. I can make some changes to the product, but I've never sent any changes back to the server. So I need to handle the save button and actually go ahead and call catalog.submit changes. And what I also want to do is I'm showing a progress dialog box. So whenever a save happens, I'm bring up a progress dialog box. I want to take away that progress when my catalog has finished its submit functionality. And so I'll go ahead and subscribe to catalog.submitted. I think I got that right. Yep. Okay, so let me run this, and then I'll kind of walk you back through sort of what the code was doing and when it was doing it. So far, Same thing here. I can load up some products. And I've got my edit button. I can bring that up. I can go edit that to, well, this thing's an extremely expensively priced thing, so I can maybe make it 99. And you can see the price shows 99 because this is all data bound to the same object instance. I've got this little information glyph here saying this object has pending changes, needs to be saved, so nothing's actually gone back to the server. I can do something similar here. I can go to make that change. Now that's also in modified state. And so I can go make a bunch of changes. Let's say I want to go put this thing here on sale. So again, now that's things modified. And so now let me go ahead and save. And when I save, what's going to happen is basically the code, the infrastructure is going to figure out all the products that had changed, what changed, package that up, send it to the server, and on the server we'll then sort of deserialize that change set, if you will, and play it through my logic here, through update product for the things that were updated, or things that had their sale bit toggled, it'll play it through this. The server will do its work, its validation, all of that kind of stuff, and update this product, and those changes are then going to be sent back to the client and updated into the client. So what we should see is all of these should go away because they've been committed.
Why did your on sale checkbox flip when you hit the sale button?
That's a good question. So essentially what's happening is when you call toggle sale, nothing's actually happened yet. Nothing's gone to the server. And so none of my client-side states actually change. Until you hit save, the server does its work and comes back. Now, you could argue that my UX here isn't appropriate because I should probably not have an on-sale checkbox because there is a sale button. I should probably have a label that says this thing's on sale. So think of it as poor UX more so than something going on. So let me click the save button. I've got a little sleep so that's just so that you can see a progress bar. And it comes back, and you see that all the products have been committed. They're no longer modified and dirty. The price on this changed. The on-sale checkbox is now checked.
If your on-sale checkbox or your sale button had been a part of your dialog box for editing, would it have updated your? Because it updated your price. Is what confused me.
The question is, what would have updated? And the answer is really nothing. The price hasn't changed because the server hasn't figured out the sale price. The on-sale bit hasn't changed because the server hasn't flipped it.
Before you hit save, your price on your Rain Racer 2000, it switched to 99 in the grid.
Yeah, because that I modified the price directly. This object is what I put on sale. And correspondingly, button now says end sale, by the way. So that's showing you that you can go make a bunch of changes on the client and then commit them as a batch. And either everything succeeds or everything fails, basically. Now let's look at this other piece of validation logic that I just snuck in. If I wanted to update a product, and I need to, the rule here says the product cannot be on sale to be modified, right? So it says if the product is on sale, then throw a validation exception. And so I'm throwing an exception on the server. Now if this were sort of, if you were calling this directly, you would basically see an exception happen. We're now calling this from the presentation tier, so what I want is to have the exception information, the error information, flow all the way back to the client so that I can actually show that to the end user. So let's take this product that's on sale right now, go ahead and try editing that. I'll just go add whatever, it doesn't really matter what. So this thing says edited. As far as the client goes, it's modified. It just hasn't been submitted yet, right? So now let's go ahead and hit save, and it's just going to be one change. It goes to the server. The message says there were errors during saving. Click OK, and this is now showing as a red glyph. Again, this is just my UX. Obviously, there's probably half a dozen better ways of showing this information. It says the product is currently on sale and cannot be modified. So the application logic said, you cannot modify this object. Here's the error. All that information flowed back to the client. And was available for data binding on the client into the UX. Does that make sense? I'll take a few questions along the way. If it goes too much, then hopefully I'll have time at the end for questions. Is that a quick question? So the question is, if I edited other products and then I hit save, what would happen? In this particular case, all the changes need to be successful or none of them happen. So they basically all remain in their modified state. None of them would be committed. You'd see the error only on one because that was the only one that had an error. Does that make sense? Okay. Let's see, what am I showing next? So I'm showing editing. Validation is an integral part of editing. I showed you how you can imperatively throw a validation exception on the server and have it go all the way back to the client. So what Brad showed earlier in his talk was metadata-driven validation, and I have some of that too. Let me show you that. So again, I'm in this product metadata class that says, here's some metadata associated with the product. And I have things like, the model name is required. I have another rule saying the unit cost must be between 1 and double dot maximum value, so it can't be 0, for example. So I've got a couple of validation rules. Let's go run those and just make sure they're working. So let's go choose to edit this one. If I go make this, let's say, 0, I should see an error saying products cannot be priced as free. So cancel that. Oh, I actually had others as well. This is required. Same thing here, basically. Oops. My bad. Demo bug. Cancel that. So you can see basically what we did was flow the validation. So let me show you what's really going on. How does this work behind the scenes? So I've got my product. I've got my metadata. What .NET RIA Services does is it projects all this information down on the client. And let's see how that manifests itself, just so you can kind of understand what's happening behind the scenes. So I've got this folder called generated code. And this is what it creates my client-side data model. And I've got a file called storeserver.g.cs. It matches the name of my store server application with a G to indicate its generated file. And in this file, I've got a class called category, a class called product, a class called catalog, and so on and so forth. So let's look at product. That's what we were looking at. So you can see it's got all these members that you'd expect it to have. And then let's look at, let's say, model name. And you can see I've got model name here, and it's got a required attribute. So basically what we've done is looked at your metadata, which describes your intent, and propagated that to the client so that the client-side infrastructure, the controls, like the data form, can pick up on that intent and do the right things in the UI. Right? So you specify your validation rule once, and it flows all the way through. Now, what we don't have in the bits today, but we hope to have, is flowing metadata all the way from the database. So your database has constraints, like this cannot be null, or here's the string length or max length of this particular field. We'd like to flow that all the way down without you having to explicitly go and put metadata in your code. Now, you can go put metadata in your code to be more restrictive. For example, if a field in a database has 50 characters, you can say, well, I want only 32, right? And so you can be more restrictive, and that will work just fine. And the same applies to the client. Your application logic on the server can say, hey, only 32 characters are allowed. Your client can come along and override that and say only 16 characters are allowed. So you can always add more metadata along the way and be more restrictive or be more specific, right? So that's part of this concept we call metadata pipeline. It flows metadata all the way through, and you can add to it along the way. So let me show you more stuff with metadata. I've shown you validation inside of an update method. I've shown you validation as a declarative metadata attribute. And we have a handful of metadata attributes like required, range, regex. And there are some basic validation scenarios you can accomplish with that. Oftentimes, you have to go and write some code. You could go write a derived metadata attribute. Or more simply, you could just go write a method and plug that into our system. So let's kind of see how that's done. So what I want to do is go ahead and add a file, add some code. I'll call it product rules.cs. And again, in the interest of time, let's just copy some code. And this is really straightforward. I have a method called ensure meaningful description. And my definition of meaningful description for the sample app is it needs to be at least 10 words or more, right? So no 2-word descriptions. Basically, it does a string.split and counts the words. Straightforward. What I want to do is plug this into my product. And so I'll go ahead and apply a metadata attribute. Go to my product metadata and say, on the description, not only is it required, but I also want to associate this custom validation rule with it, saying, here's the class, here's the name of the method, and here's the error message, right? And so now I've got this rule that's going to run on the server. What if I actually want to have it run on the client as well, right? Because it's fairly straightforward code. All this functionality of string splitting and counting exists on the client as well. I should be able to run this there. And I've already gone ahead and marked this as shared to indicate I want to have it run on the client. The pattern we have for shared code is to simply name the file shared.cs if I'm using C# or shared.vb if I'm using VB. And so now I've marked this file as shared, and that's going to get propagated to the client along with the metadata attribute that says description is associated with this rule. So let's run that. Let's build this. And so the reason why I showed you that generated code is so I can show you what just happened here as well. If I go to my product description, you'll see that the custom validation rule was propagated as well, along with the definition of what the rule is. And so in addition, what you should see is product rules.shared.cs also got included into the client project automatically. You didn't have to do that. So part of this idea of your client and your server belong to a single application implies that you're not just sharing a contract, but you can also go share behavior. And there's a set of constraints around it, obviously. You can't run all your server-side code on the client because some of those APIs don't exist. Or you might be accessing data to do the validation that doesn't exist on the client. But within the realm of what's possible, you can go write code once and actually have it propagate and flow down to the client. So let's actually make sure this actually works. Run this again. While this is loading, I can now choose to edit. And let's just, so this is required, right? Because the required rule triggered, the custom validation rule did not trigger. This is some description. And now my invalid rule says the description must be a full paragraph, right? So my client side, my validation rule is now running on the client. And obviously this will run on the server as well. I don't need to show you that. You've seen that. So that's custom validation. Let's see. What else do I have to show you? Okay. Let's go back to slides for just a second. So this showed you, just to recap, this showed accessing your application logic directly from the client. Showed you using link queries on the client, sending it to the server. Showed you editing, validation, custom validation, CRUD extended with some custom operations like toggle, sale, and it showed you batching. So I could go do multiple edits and send all of them in one shot to the server. So we have a prescriptive pattern. I said we were trying to be prescriptive. And so what is the little bit of prescription that was at play over here? First is you've got your data model, your product, and what you go write is a domain service. And this is optimized to be stateless. It's optimized to run on the server. It contains your application logic along with CRUD methods. It takes the form of query methods, update methods, custom methods, and you can go annotate the methods and the models with rules about validation, authorization. Brad showed you authentication. I didn't go into that. You can go write some code that triggers application workflows, and so on and so forth. You basically have a place to go write your code, which forms the guts of your application. So this is what you write. we inspect what you write, look at the code, look at the structure, flow the data, the metadata, and the shared code, and produce a client-side data model, which takes the form of a domain context. This catalog that I had on the client derived from domain context. And it is optimized to be bindable into the UI. So it is stateful. It has lists of objects. It raises change notifications, allows you to load data asynchronously into it, allows you to track changes, submit changes that have been made all the way back to the server. So that's what the pattern we have so far is. And there's things we can go build on top of this pattern. For example, authentication in .NET RIA services is modeled on top of this same pattern. It's just a more specific sort of structure, if you will. Instead of having arbitrary methods, it has a login method and a logout method. It has a get user method, which returns the current user. And correspondingly, a client-side view of that is created. But I actually wanted to show a little bit about how this pattern extends further than just Silverlight. Because a pattern that only fit a very narrow sort of slice would not be very useful. So far what I've been doing is a database. I've been using link to SQL to get to it. And then I have a Silverlight client. So while I had a database-backed entity on the server, nothing in our system really depends on there being a database. It's really all about CLR types. So I can have any arbitrary list of data, any arbitrary object, and work against that. For example, if I have a repository that just surfaces some CLR types, I can plug that in. I can have my application logic work on top of that. Also, very interesting is services. I might have other services in my enterprise, like there's this customer tracking system that exposes a service that I want to reach out to. There's this order processing system, or there's this HR system, what have you. All sorts of in-house enterprise services that I might want to consume. Or I might have third-party services, like, hey, I want to write a bookstore kind of app, and I'm using the Amazon service. I can go plug that into this pattern. Or I might be taking my own data, and rather than storing it on-premise, I might be storing it in the cloud. Whether it's S3 or even better, Azure, you can go plug this in without the pattern changing. That's the key thing. And I'll show you a demo of that. On the other side of the pattern, you have presentation tiers. So I've shown you Silverlight. All this applies equally to WPF if that's what you're writing. And that's a .NET to .NET sort of picture. But all of this is accessible. It's built on sort of standard open services, protocols. And so you can go use AJAX to go get to the same application logic. You can do server-side rendering and project out HTML. Brad showed you SEO, search engine optimization, using this. I'll show you another demo in the same spirit in a moment. So these are sort of UI, user interface clients. I can also present my application logic to other applications and present it as XML, JSON, binary, whatever have you, and write services in WCF that go and allow me to project my functionality that I have written to other applications. So what you can see is this application logic is the central piece, and it's the guts of your application. It's sort of like an interesting asset that you're building that can be reused in different ways, and it helps you encapsulate your choice of database or data technology so that you can, if you ever have to migrate, you don't have to change everything else in the world when that happens. So it's interesting to be able to go test this. And so what you can also imagine is that you can unit test this application logic independently of any particular UI tier, UI code, and you can go mock out the data store so you can test your application logic in isolation. So let me show you a few demos, just kind of having a little fun with this pattern. The code, I'll show you little bits of code. The code isn't the most important thing. It's just to kind of see how this pattern scales and applies to more than just the obvious scenarios. So let's, the first thing I want to show is accessing this logic and doing server-side rendering. So what I have here in this application is a print button, and I want to go print, let's say, the particular product. Now, Silverlight today does not have printing, right? But the browser does have printing. If I can go create an HTML document that contains the same data, I can then use the browser's print function to get that functionality for the end user, right? But I don't want to go duplicate all of my work. I want to leverage some of the work that I've already done while building my catalog class. So I can choose print. This will bring up a different page. So you can see it's print product.aspx $ID equals 355, right? And then I can go choose to print this, obviously. And this is actually trying to bring up the print dialog, which I should have probably commented out since it's probably trying to hunt for the printer now. Okay, we'll skip that, and I can show you the code. So print product.aspx. I've got a domain data source. This is a server-side domain data source. I'm telling it what object to go against, and it's the same catalog that I wrote. Oh, there you go. It's doing something. Let it keep doing it. I'm telling it I'm interested in products, and the method I want you to call is getProducts. Now, getProducts did not take a parameter. I'm passing in the parameter using an ID query string, and so this is where my query string parameter gets plugged in, right? And it's basically doing a link query on the server against the iQueryable returned from my get categories, or get products, sorry. So just to kind of refresh, here's my catalog, get products, returns iQueryable product. That's what my data source uses. It passes in the ID through the query string. And then what I've got is standard ASP.NET markup. How many people have used ASP.NET, used ASP.NET? Great. So what you can see is basically some standard HTML. And this, for those who haven't used ASP.NET, this angle bracket %pound basically says data bind. And so I'm binding my form view, which is sort of like a data form on the server, to the results of the product data source. So it enumerates the products. It finds the single product that matches the ID. And then it creates all of these, it binds to all these different pieces of data off of a product and displays that in some HTML that happens to look like this, and the dialog finally came back. So here's the dialog. Using a little bit of script, I can pop up a dialog to say print. If I were on the network, I would have this sooner. I can choose print, and now I have, basically what I have is print functionality that's fairly reasonable, functional for the Silverlight app without depending on Silverlight itself to do the printing. The key here was I reused my catalog class. So I had some logic that says discontinued products cannot be accessed, right? I don't have to re-implement any of that logic just because I'm now supporting printing. All of that logic is there in one place, and it's being reused. So that was server-side rendering. Now I want to show you a little bit of AJAX. How many people have done AJAX? How many people use jQuery? A few hands. So I'm going to be showing that. So I thought I'd pick jQuery. It represents one of the most popular AJAX frameworks out there. And so here's my code. I've already written it. And this is $.getJSON is basically a jQuery way of saying issue a web request to this particular URI. And then when the data comes back, execute this function. And this function basically says I'll enumerate all the data, iterate through the results, and produce a HTML rendering for every product that comes back. And here's the template for how I want each product to be rendered. And this angle bracket % equals, very similar to angle bracket %pound, is the equivalent for the jQuery syntax for binding. So you can see what I have here is a honest-to-goodness actual service that speaks JSON and is consumable from a sort of standards, non-Microsoft sort of technology, just perfectly fine. So let's run this. Oh, it's already come up, actually. Here's my product list. Basically, it issued the request, came back with the list. So that's AJAX. The next thing I wanted to show is on the other end, sort of a different database or different data technology. Rather than using a local SQL database, I wanted to show using Azure. So let me open that solution. So let me set this up a little bit and show you what's going on. So again, I have the same pattern. I have my data access folder, which is going to define my model and how I access my model. So I've got a book class that I just wrote here on the server. This derives from an Azure entity. Every entity in Azure has a row key, a partition key, and a timestamp. This helps the Azure storage system figure out where to store your data in terms of which data center and how to go store it so that you can then later access it. Right? So that's what you get from entity. And I've gone ahead and added title, author, image URL, and URL to what makes up my book class. Right? And the same things around metadata, all of that applies here as well. Just because it's Azure doesn't mean the world's just changed. All of that same programming model equally applies over here. Right? So that's my book class. And then I've got a books data context. And now I've taken the Azure SDK that comes with Azure and written a little wrapper on top of it that makes it very simple to access Azure data in very consistent manner to things like link to entities and link to SQL. So I've got my books DB data context derives from an Azure data context. And here's where I'm passing in connection string that tells what URL to hit, and here's what the public key is, and so on and so forth. And then I've got my books class, which is an entity set of book type, right? So that's my data model. I've got my entity type, and I've got a class that lets me access a list of those entities. Now I want to go write my logic. And I've got a class now called bookshelf. This represents the ability to go get books and modify books. Instead of deriving from link to SQL data service, this derives from Azure domain service, right? And then I've got my query method. So I've got get books, and this just returns all the books. I've got add book, and I'm inserting that into my Azure data context. In addition, I'm also setting the row key. Part of my application logic is to set up a key for every object that goes into the store. And then here's my update book, very straightforward, just takes these two objects and saves the updated object. So that's my code on the server. As you can see, it's very similar, and that is part of the point that the pattern is applicable. The same pattern is applicable. And so if I now go to my main page on my UI, I've got, this time around, I'm using the domain data source declaratively, so I'm not doing anything in code. Here's my domain data source. It points to the bookshelf. It says use the load books method. And then here's an accordion that I have that's going to show the list of books in an accordion control. The accordion is a new control as part of the Silverlight toolkit. And you'll see what it feels like in a moment. And then I've got my data form, the same control, bound to a book, so I can go edit the book. Let's run this. And so now it's actually going to Azure, to the real cloud. It's actually working against the real cloud. I've pre-populated my store with 4 books, and so I can go pick a book, and this is the accordion control. You can have it either vertically or horizontally. I made it look like a bookshelf, so to speak, a little bit. So fundamentally, nothing really changed in terms of the pattern. I still use the same UI controls. I still had the same pattern for writing my application logic against Azure. And just to show you, it is really Azure. I'll bring up HTTP trace tracing tool, and let's run this again. And you can see it went to it went to slash, where did it go? Like, here's the host, demo.table.core.windows.net. That's my demo store on Azure, or demo app on Azure. And then here's the URI. It says get the books, filter by so-and-so partition key, and it returns basically all the book information as an Atom feed, basically. That's sort of the Azure request response model. So let me show you one other thing, and this is specific to Azure. So my CRUD methods were pretty similar. Here's my Azure specific stuff. I have this method called getPartitionKey that I can override. And in this particular demo, it just returns a hard-coded value bookshelf. Let's say I was writing a real application that was meant for use by multiple users, and each user had a bookshelf of their own. And I wanted to partition all the data in my application according to the user, so that user Joe's books are all in this partition, and Bob's books are all in that partition, because my queries are typically going to be scoped within a particular partition. So part of my application logic is to figure out what is the partition key that I want to store all of my data in, and that is nicely encapsulated as part of my bookshelf class in this thing that derives from Azure Domain Service. So now what you can see is not only does this abstract away the choice of data technology that you're using in your particular application, but it lets you do anything that is specific to your choice of data technology inside this class. So if I was doing a printing scenario, or I was doing an AJAX scenario, or I was doing a service, I was building another service on top and exposing the bookshelf as a service, I don't have to track the logic to determine partition key everywhere. It's encapsulated in this. And so this is part of the appeal for this pattern, so to speak. So that shows you Azure. The last thing I want to show you is offline and out of browser. Specifically, it shows how this pattern on the client that we have, this domain context that has a list of entities, a load method for the entities, and a submit changes for saving all the changes that were tracked and sending them back to the server. How that helps you create offline apps. So let's close this and open up my offline solution. So what I have here is the same catalog class on the server. I'm using the same. I'm using this exact same application logic. I didn't change anything over there, right? Offline is pretty much going to be handled on the client. What I have here now is I can go ahead and create the catalog in the same way. And what I've done are a couple of things. I've attached a couple of behaviors to this catalog. One that says local sync behavior, and it runs every 10 seconds. Basically what this does in particular is it saves all of the data that's on the client in the catalog class into isolated storage, into a file called catalog.json.txt. And not only does it save all the sort of products and categories, but it also saves all the changes that I've made that haven't been submitted yet, right? So it's saving the entire state of the client, so to speak. The second thing I've done is attached a server sync behavior, and this runs every 30 seconds, and it says every 30 seconds go ahead and see if there's anything new to load in terms of load categories and load products. So anytime there's anything new on the server, go ahead and bring it down. And the infrastructure already understands how to merge whatever is coming back from the server into the client. So if you've got the rain racer product on the client and the server sends another rain racer, you're not going to get two rain racers on the client. You're going to get one, and it's going to have the merged state of whatever is new on the server into the existing rain racer, right? So basically, I've essentially added these few lines of code that sets it up to be saved locally and to be synced with the server, right? So let's run this. So same application, but what I'm going to go do now is install this application using the Silverlight out-of-browser feature in Silverlight 3 that was just introduced. And so I'll go ahead and choose to create a shortcut on the desktop. And so it will show up there, and you can go run it. So same functionality, right? Now what I can go ahead and do is let's try to make a couple of changes. So let's say I want to change this to 109, and I'll just, for the sake of showing it, I'll say edited. So this thing's been edited. Every 10 seconds or so, the functionality to go save the changes to isolated storage kicks in. It's going to save off all these products, all these categories, as well as the change I just made. I can go close this application. And this is demo code, so I'm going to pray it works. It worked. Thank you. So it's still modified. I closed the application. I brought it back up. All the changes were just saved. And I could be offline. I could literally be offline. I could disable my network. It wouldn't help because I'm actually accessing HP localhost for the demos. But you have to trust me on that. But more importantly, besides just being disconnected, it shows you that the changes were saved and they were restored when I brought the application back up. So I can now go ahead and actually click save because I am connected. It will go ahead and execute the same functionality as before that I showed, right? And now my changes have been saved. I can go again, close it, and I can go bring it back up. And now you'll see that something didn't work because I closed it too soon. All right, well, let's try this again. Where was I? Okay, let's save this. Saved. I should talk a little bit so that it actually goes off and saves it off to isolated storage, right? And keep my fingers crossed and pray. Close. All right, there you go. Okay, so what did this just show? Part of our pattern was around understanding your application logic, understanding the CRUD operations, understanding the custom operations, producing a client-side data model that was suited for not just binding, but also offline storage, where you can go take the entire state and save it off locally, and replay that state when you bring the application back up, and then actually make the changes when you have actual network connectivity. So that was part of what you get from the program model. Since the very beginning, when we've been thinking about how we want to structure our APIs, what are the sort of tenets, offline has been a key part of it since day one. We wanted to create a program model that scales to offline without you having to fundamentally change how your application architecture is. So I think that brings me to the end of my demos. I have 2 minutes. I heard things are running late, so I might have 15 minutes. But anyway, I'm here for questions, so thank you for sticking through. I will be putting the demos out on my blog, nikhilk.net. Brad has a blog too, where I know he's going to be posting some stuff today. Silverlight.net is our place where you go to get all the information right now. We'll be having CTPs of all of our technology. We are eager and anxious to hear your feedback and in using this stuff in real apps. Thank you. Over here.
Yeah, I have a question about the shared code. Why is it actually making a copy and putting it into the project that is the Silverlight app instead of like a shared assembly that could be used between both? And do you need to have both of these projects in one solution for that to work?
Okay, so there's a couple of questions there. Why does shared code work as a copy? Now, shared code works as a copy as opposed to a compiled assembly that's shared because we allow you to use partial classes. And partial classes work at the source level, not at the assembly level. The second part of the question was kind of alluding to how do I share these across multiple projects? Do they need to be in the same solution? Yeah. Today, yes. We're certainly interested in catering to the sort of the class library, if you will, where I can go create a class library of my application logic, get an equivalent class library of my client-side logic, and share that across multiple applications in different solutions. So it's on our roadmap. It's not there in the beta that you'll see today. Is there any? There's no questions there, so we're here.
A couple of questions in regards to the out-of-browser mode in Silverlight. First was printing. I'm wondering if you're in out-of-browser mode, can you still activate that print button and spawn up a window for print?
You can. So in out-of-browser mode, you can have a hyperlink button. Have the hyperlink button point to the URI that is your printing page. Have a target property on the hyperlink button, and when you click that, even out of the browser, it will pop up a different browser window. I haven't tried this myself, but I sent a mail because I was thinking of the same thing to the person responsible for the feature. If it doesn't work and you try it, let me know. I will.
Can we try it with your demo app?
Smart. I might not have used the hyperlink button. That's the. It's very likely that I did not use a hyperlink button.
And in regards to merging data, what happens if you have a pending change and that particular record gets updated?
Okay, so when merging happens, you have different options. You have the option of replacing whatever you have locally with whatever comes on the server. You also have the option of copying everything that came from the server that you haven't modified, but keeping your modifications. And so I believe the default is to keep your modifications, not overwrite what comes from the server. Now that might result in a conflict later on, right? Because you've got essentially a row that's been modified on the server as well. And I didn't get to show you today, but there is a story for handling conflicts as well. All right.
I have two questions. The first is, under the hood, is the code-generated proxy leveraging ADONet data services?
I'm sorry, what?
I'll repeat that. Under the hood, is the code-generated client proxy
Yes.
leveraging ADONet data services?
Is it leveraging ADO.NET data services?
Yes.
Great question. We are, and Pablo might still be in the audience. We're working with the ADO.NET data services team to try and make this all be part of a single continuum. So yes, the answer is yes, you will be able to look at the service that's created as an ADO.NET data service.
Okay.
The .NET RIA services programming model is around making the object available for direct use at the API level. So you don't have to look at the service, but you will, in fact, have a service.
And my second question is in regards to the method attributes for validation, both on the server side and generated to the client side. Can that be specified in a config file in a more abstract way?
The answer is generally yes, but there's a number of limitations we have today where you might run into them. Our general model is we have attributes as the runtime representation of your rules. So the fact that a property has required tells us it's required. It doesn't tell, you can go plug in different ways of loading metadata. So the one that we have and the one that works today is it loads it from the actual assembly, but the general architecture is set up to allow you to load it in from an XML file, from a database, so you can go externalize your rules from the actual model.
Okay. Thank you very much.
Yep, you're welcome.
Over there. The other microphone?
Oh, there's a question. Thanks. Go ahead.
Many data-driven applications that run in the browser have a way of trapping it so that if the user has entered something and they attempt to close the browser, it will bring up a confirmation dialog saying it's one of the on-close events in JavaScript. What's your story for providing that for Silverlight-based applications running in the browser?
So today the story is still handling the browser event and prompting the user, and then it's up to the user to figure out whether they still want to go ahead with the navigation.
Okay. Do you have a way of providing that prompt using a Silverlight-based window rather than the browser window?
No, there isn't really, because the browser, you in fact don't even get to customize the string that the browser shows, because the browser looks at that from a security perspective, not be able to spoof the user, misguide the user, trap the user into not navigating away. And so navigating or closing the browser is really out of control, and so you kind of live within the browser Chrome's limitations. And that is, in fact, one of the appeals of going out of browser, is you get to determine the overall application lifecycle better once you're outside the browser. I'll take another question.
Okay.
I think
You didn't really talk about paging or filtering in detail. Are there examples somewhere how you can implement this in Hibernate and other data sources to actually work with the standard controls?
So Brad showed paging and filtering. The general model around paging and filtering is based on iQueryable. You can certainly also have methods that take parameters. That's still there. And that is intended to work with any data store, as long as the data store itself supports iQueryable and passing and filtering
so
and so on.
in essence, I have to go and implement that interface to make it work seamless.
Depends on what your data source is.
Yeah, okay.
Okay.
I got one more question. Do you have any...
We'll take one more, and then I think I'm being signaled that I should be done. So I'll take other questions offline over here.
The RIA services as such, that's part of the toolkit?
How is RIA services being handed out? Today's a CTP that you can download off of Silverlight.net, I believe, and it installs on top of Silverlight 3 and on top of VS 2008.
Okay, thank you very much, sir.
Thank you once again.